This is the second video in integral calculus. In this video, we're just going to consider some simple area problems. You remember area. We can look at equation of a line and graph it, and then we can think about the area that line makes between itself, the x-axis, the y-axis, and some boundary at x. And we're going to do that in a few cases, and we're going to write down the equations. And then I'm going to ask you a question. So this video is going to inspire you. So think carefully about what we're doing, and you may want to watch it a couple of times. Okay, so our first example is very simple. It's a rectangle. It's a rectangle between the line y equals 4. I'm going to write the equation. And the x-axis. And we're only going between x equals 0 and something we're just going to call x, some unknown value of x. So this is a rectangle that could be very skinny over here, or it could be way out closer to infinity. But we're just going to call this point x. And remember, the area of a rectangle is the base times the height. So the base is x, whatever distance x is, and the height is 4. So the area is just 4x. Simple, right? Nothing confusing about this. Okay, now let's look at the next example. In this next example, number 2, we have the line y equals x. So y varies as x varies. Y isn't a constant anymore. Y equals x. And now we're looking at the area of a triangle because y equals x intersects the x-axis at 0. And we can make a triangle with any x value. X equals 2, x equals 4, x equals 10 million, except we don't want a line over there. We're just going to call this point here x. So we can come up with a formula for the area that this line y equals x makes the area of that triangle, no matter how large or small x is. And you have to remember that the area of a triangle is 1/2 the base times the height. Now remember here the base is still x, but because y equals x, the height is also x. Wherever we go, x and y are the same because that's the equation of this line. That's what's always true, y equals x. So the height and the base are both x. It's x squared, but because it's a triangle, it's 1/2 x squared. 1/2 the base times the height. Okay, now let's look at the last example. The last example is not a triangle or a rectangle, it's both. Here we have the line y equals 2x plus 3. And it makes kind of a trapezoid. If you consider the y-axis, starting at x equals 0 and going up to any vertical line x. Because y equals 2x plus 3 has a y-intercept of 3. So we have this rectangle on the bottom here, this part, and it has a base of x and a height of 3. So part of it has an area of 3x, the rectangle at the bottom. And then we have a triangle at the top. And the base of the triangle is x, right? It's going to be 1/2 base times height, 1/2 x. And what's the height? That's the interesting thing here. So this point up here is, if the input is x, is 2x plus 3. And this height is 3. So 2x plus 3 minus 3 must just mean that this height is 2x, right? 2x plus 3. So the height of the triangle is just 2x. You might have to go over that again for yourself a couple of times. But if we simplify this, the area of that trapezoid is 3x. Oh, this is not coming out pretty. Let's try this one more time. I want it to come out at least dignified. The area is 3x plus the 2's, 2 over 2 is 1, so just x times x squared. Let's just really make that look like an x. Okay, so you have 3 examples, and I want you to look over these 3 examples. Maybe you'll even want to write down these equations, these pairs. In each case, you have an equation of a line. It makes a certain area. If you look at the space between it and the x-axis, between 2 values of x, 0 and an unknown value of x, and we got the area, because each one of our shapes was a simple shape that we could get the area for. A rectangle, a triangle, or the sum of the 2 things. And I want you to look at these things, and I want you to notice something. Going back to the title of this video, it's an interesting phenomena. I want you to notice the interesting phenomena. And I want you to write down what you notice in the question on your Google Classroom, and then we will discuss it.